Hey, I'm Prashant. I'll be introducing the project and talk about the system functionality.
We are Team 104, the black sheep plagiarism detector, and we find plagiarism in Python files. So, some of the languages and tools that we have used to develop this application. For front end, we are using HTML, CSS, JavaScript, and jQuery. The backend is developed in Java, and we use MySQL to store the data. To connect the front end and the back end, we are using Spring Boot application. We are also using tools like Jenkins and SonarQube for quality checks. On the deployment part, we are using AWS as the hosting platform, and we use AWS S3 buckets to store the uploaded files. S3 CloudWatch is being used for logging activities. A quick introduction to the team. We have Manpreet, Tong, Atul, and me, Prashant. So Tong has developed has been taking care of the DevOps, and Atul is mainly involved in front end development, and me and Manpreet were involved in the back end development. So a quick look at the system functionalities. We have the register, so a user can register as a TA or a professor using the email IDs. We have the login screen. We have the upload submissions. This is to upload the multiple submissions of more than 2 students, or it's for n students. We see the results as a percentage match between 2 files, or we can see the line by line code match. So some of the major algorithms that we are used in order to detect the plagiarism is comments match, structure match, and the code match. Comments match basically checks if the 2 comments are same across the 2 files. This uses edit distance algorithm. Structure match basically checks the structure of the AST if it has matched across the 2 files, and the code movement checks for the subtrees between the 2 ASTs, that's between the 2 files.
Hi, I'm Manpreet and I will be talking about the quality report and the team composition and our methodology for the project.
We have connected the Git repository with SonarQube and Jenkins for continuous integration and the quality check. We cannot commit the code directly to the master. For every merge, a pull request is created, which in turn triggers the quality check in SonarQube. Only if the SonarQube returns a success and our test coverage is above 85%, does it allow a merge into the master. So once all the checks have been completed, the reviewers can go ahead and approve the pull request, which then is available for merge to the master. Teamwork. Our team composition is we have one DevOps person who handled all the Jenkins and SonarQube setup and maintenance. 2 people worked on Java APIs to receive data from the front end, return results to the UI, integrate all the algorithms and implement design patterns. 1 person worked on front end of the application. We followed agile methodology. During sprint 1, we had daily Slack meetings for 15 minutes where each team member addressed the following questions. What was done the previous day? Is there any blocker? What is the plan for the next day? Sprint 2 onwards, we started meeting in person and had daily stand-up meetings in the library, which followed the same standard procedure. For development, we followed peer programming, and always 2 people were paired together to work.
Hey, I'm Tom. I will speak about the accomplishments and key features of our system. We deployed a live system which is successfully deployed on AWS, and the accomplishments of our system include: first, our system is very user-friendly and it has very intuitive UI and UX. And second, we have 2 different roles, professor and TA. and a new user can register and log in as a professor or TA. And we also check whether the email exists or not during the registration. And besides, our system supports multiple submissions, and the user can choose. We have three different detecting strategies. A user can choose which strategies he or she want to use for detecting. Finally, the user can view the results as the overall percentage and view the detailed code matches. And now let's move to the next slide. The key features of a system are first, and the user can select detecting strategies that according to his or her demand. And besides, our systems supports side-by-side comparison. In the detecting results, users can see the detailed matched codes, and these codes are highlighted with different colors based on the different match types.
Hello everyone, this is Atul. I will be speaking about the process, challenges, and future updates. Starting with the process, it is always simple and straightforward. Tasks were planned for 3 sprints, implemented with smart commits to reduce the management overhead, and approving them after a green signal from SonarQube and Jenkins. Quality was always our prime focus, as we felt the technology transfer must be a cakewalk. Last but not the least, thanks to Alex for helping us out with the quality gate issues.
Moving on to challenges, we faced a lot of them and resolved it over time. One big challenge was choosing the right technology versus using the technology that we are used to. Hence, the obvious solution was building a web app in Spring Boot with HTML, JavaScript, and CSS. Frontend was one important section where none of us had a hands-on experience before. Feature-wise, the code match screen was really tricky. Rather than just displaying a percentage, displaying the actual reason for plagiarism to the user is really important. Most of the times, just a number doesn't really help. As a team, we came up with a plethora of ideas. Some features that our team members proposed were really cool, but we had to take a hard decision as a team to put them on the waiting list for the next release. Whenever there was a deadlock, we resorted to getting feedback from our TAs, friends, and professors. Because in the end, it's all about the user experience. Most importantly, it is always simple to build a complicated design, but it's really complicated to build a simple design. Moving on to the future updates, we will be rolling out a number of updates by categories in the upcoming releases. Security is one major section that we will improve. Now, the authentication is really simple. The first update will be adding a stateless authentication using JSON Web Tokens. Stability is also one major concern. There were a couple of issues reported by users about browser crash while using certain builds of Chrome. For a seamless experience, we will be reducing the number of AJAX requests and converting synchronous calls to asynchronous calls. Regarding the browser support, soon the web app will be available across all browsers, but at this point of time, it is recommended to use Chrome. There is one more new feature coming up. The current release enables a user to see a project-based comparison in the code match screen, but in the next release, file-based comparisons will be available. Thanks a lot for watching our video. Stay tuned for more updates.